We're going to discuss today how to convert radicals, entire radicals and mixed radicals. And so what we're going to talk about is the concept of what is a mixed or an entire radical first. So you can, when you're looking at radicals, we talked yesterday or in the previous video about the fact that this part is a radical where you have an index and then inside you have what is called the radicand. Okay, now when you have a mixed radical, what you have is a radical. That's what this whole thing is here. Okay, and then you have a number out in front of it, a whole number out in front of it. So for example, 4 root 3 or 3 root 2 or something like that. That's a mixed radical. Okay, and then an entire radical is just a radical like the 4th root of 25. Okay, so a mixed radical is actually a way of simplifying an entire radical. And we want to know, how do we go from one to the other? Okay, how do we go from an entire radical to a mixed radical? In other words, where does this number come from out front? Okay, so to do that, what we're going to do is we're going to prime factor the number under the root sign, put the prime factors into equal groupings of the index, and then split the radical into groups of prime factors in the remainder, and take the root of the groups of prime factors. And you might think, what in the world are you talking about? But hopefully you remember, first of all, how to prime factor. And then, so we're going to start, we're going to do this example, but I'll do it up here so you can see the steps. So we're going to start with 80, and we're going to try to prime factor it. So 80 goes 2 times 40, and then that's 2 times 20, and then that's 2 times 10, and then that's 2 times 5. Okay, and that's prime factored. So I've prime factored the numbered. And the prime factorization is 2 times 2 times 2 times 2 times 5. Okay? Then we're supposed to be putting the prime factors into equal groupings of the index. So what that means is the index here, because there's nothing written here, is a 2, right? We said it's a square root. So we're going to put these in groups of 2. So there's one group of 2, and there's two groups of 2. Okay? So what then we do is we split the radical into the groups of prime factors and the remainder. So I get the square root of, and then 2 times 2, 2 times 2, and 5. And that really is the square root of 2 squared times 2 squared times 5. And then we take the square root of these prime factors, okay? So it's 2 times 2, take the square root of those and leave it as root 5. And what we then end up with is 4 root 5. Okay? So that's the steps that you can follow. Now that is sort of what we're doing, but there is a more efficient way or a quicker way of thinking about it, is if you know your perfect squares or perfect cubes or perfect fourths. Okay, so in this case, I know my perfect squares. And so what I'm looking for really is I can just, instead of writing it as 2 times 2 and 2 times 2 in here, I can write that as 4 times 4, which is 16. So I can just write this as 4 squared times 5 instead of 2 squared and 2 squared, if that makes more sense to you. And that then becomes 4 root 5. Okay, so you're looking for a perfect square factor. So let's do a couple more of these and I'll show you how this works. If you look at this one, it's first of all going to be prime factored. So this is 12 and 12, and then 12 is 3 and 4, and this is 3 and 4, and then 4 is 2 and 2, and 4 is 2 and 2. So the prime factorization ends up being 2 to the 2 times 2 times 2 times 2 times 3 times 3. And then what we're supposed to do is take that prime factorization, look at the index, which is 3, and put it in groups of 3. There's only one group of 3 that I can get. And then this is my leftover. So my leftover is 2 times 3 times 3, okay? So I'm going to rewrite this radical now as the cube root of 2 cubed, okay, 2 times 2 times 2, and then times, and then I'm just going to multiply this out. So 3 times 3 is 9 times 2 is 18. And then I take the cube root of the 2. So I write the 2 out here. So it becomes 2 cube root of 18. And that's my simplification. Sorry, I'm stumbling over my words. All right, the 4th root of 162. So we're going to try to get, again, prime factorization. I'm going to start just by going 2 and 81. And then 81 is 9 times 9, and that's 3 and 3, and that is 3 and 3. So what I do is I notice that this is the prime factorization is 3 times 3 times 3 times 3 times 2. And then I look for a group of 4. So here's my group of 4. Okay. So then I write this. So when we look at this, that is 3 to the 4th. So I'm going to write this as the 4th root of 3 to the 4th and then times 2. And then I'm going to write the 3 out front. So I get the 4th root of 2. So I get 3 4th root of 2. That's how I simplify it. Okay. So here's another few examples. It says write the radical in simplest form. So I say, okay. And I start by prime factoring 40. So 40 is 2 times 20. And then 20 is 2 times 10. And 10 is 2 times 5. So my prime factorization of 40 is 2 times 2 times 2 times 5. And then I look for a group of 3 because the index here is 3. So I try to group them, and I can, one group of 3 there. So I'm going to rewrite the cube root of 40 as the cube root of 2 cubed times 5. And then that becomes 2 cube root of 5. For 26, it's 2 times 13. Okay? So when I look at that, I say, okay, well, there are no groups of 2. The index here, right, not written, so it's a 2. There's no groups of 2, so there's actually no way to simplify that. There's no way to make that a mixed radical. So that's just my answer. Okay? The 4th root of 32, 32 is 2 times 16. 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. All right? So I group a group of 4, 2 times 2 times 2 times 2, and I get the 4th root of 2 to the 4th, and then times 2, because there's this 2 left over. And so that becomes 2 4th root of 2. All right, now, then the question is, how do I go the other way? How do I go mixed radical to entire radical? And basically what you do is you take the whole number and raise it to the power of the index, and put it inside with the root. So essentially with this example, what we do is we write this as the cube root of 4 cubed times 5. So you're bringing this 4 in and raising it to that power. Okay? And then that becomes the cube root of, you have to know 4 cubed is 64 times 5, and that gives you the cube root of 320. Okay, that's the idea. So it's actually easier to go to a mixed radical. So here's a few more examples. We're going to take this cube root, we're going to bring the 3 inside and cube it and multiply it by 2. So you have to know 3 cubed is 27 times 2, and so you end up with a cube root of 54. So that's the entire radical that matches that mixed one. 2 fifth root of 2 becomes the 5th root of 2 to the 5 times 2. 2 to the 5 is 32. Sorry, that's a 5, not a 3. 5th root of 32 times 2. And that becomes the 5th root of 64. And then 4 root 10, you write that as 4 squared times 10. Again, because the index is actually a 2 if it's not written, so that's where I'm getting that squared from. So that becomes the square root of 16 times 10. And that's the square root of 160. Okay, so that's how we go from mixed to entire. So I'm going to leave you to try the rest of those questions from your textbook. You should have access to on your own.